Hi, and welcome to Pre-Calculus. Today we're going to go over the notes for the prerequisite chapter number 3. So we're going to be talking about lines in the plane. So after you write the title, print your first and last name and what period you're in. So the first thing on our agenda is the slope. To find the slope of a line, you're going to be finding the rise over the run. The fancy notation that we start using in pre-calculus and calculus is this little triangle that's called delta. So delta y over delta x. That's fancy for change in y over the change in x. So the formula is y2 minus y1 over x2 minus x1. And whenever you see it in the slope, in the equation of a line, you're going to see the number plugged in for m. Usually a fraction, but not always. So for these 2 points right here, we have a point at 2, 5, and a point at -2, -1. So we're going to plug those numbers into the 4 spots into that formula. So 5 minus -1, and 2 minus -2. Minus minus is plus, so you get 6. Minus minus is plus, so you get 4. And 6/4 reduces to 3/2, so the slope is 3/2. Okay. If you have a coordinate plane available to you, you can also just graph the 2 points and then count up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. And you would get 6/4, which reduces to 3/2. Okay? All right, so we're going to find the slope of the line given 2 points again. So one of the points is at 0, 4. It's right here crossing on that line. It's kind of hard to see. And another point over here at 8, 2. Okay. This one is a negative slope because it's going down, right? So we're going to have plug in our points. 2 minus 4 and the 8 minus 0. Remember that the y is in the numerator and the x is in the denominator. 2 minus 4 is -2, and 8 minus 0 is 8, so -2/8 reduces to -1/4. All right, this one happens to turn out a little bit weird. So if we're going to find a line of a point with points -3, 6 and -3, 0, what you're going to notice is this line is straight up and down. When we put our our x's in the denominator, we get -3 minus -3, which ends up being 0. So if you have a 0 in your denominator, your line is undefined. It's basically, it means it's a vertical line. Okay? All right, so now we want to find the slope-intercept form of the equation of the line. So hopefully you remember the equation is y equals mx plus b. Like I already told you, m goes, whatever slope you get goes in for m, usually fraction, but not always. And whatever your y-intercept is, goes in for the b. Okay, so for the first one, we have a point at 5, 8. So you go 5 to the right, up 8, put your point, and the slope is 0. 0 means you don't go up any or down any. You're just going straight across. That's a horizontal line, meaning it's 0x plus 8. So you can simplify that to y equals 8. Okay. The second problem on this one has a point at 1, -4. So you go over 1, down 1, 2, 3, 4. And from there, your slope is -1/2. So you're going to go down 1 over 2, down 1 over 2. That's going to show you where your line's going to go. Well, look right here where it's crossing the y-axis is a little bit tricky. It's not exactly at a corner, right? So to get the number that goes there, we're going to plug in the point 1, 4. We're going to plug in 1 for x, and we're going to plug in -4 for y, and we already know the m. So we're going to plug those 3 numbers in. The only variable left is our b. So we're going to solve for that b. If I multiply -1/2 times 1, I get -1/2. If I add that 1/2 to both sides, -4 plus 1/2 is -3.5. So that's what plugs in for b over here. And the slope They gave it to us in the question, so that part's easy. All right. Next box. Find the slope-intercept form of the equation and graph the line. So for the first one, we're going to take the 5y minus 2x plus 15, not in slope-intercept form. So first thing we need to do is get it into slope-intercept form. So I'm going to add 2x to both sides. I'm going to subtract 15 from both sides. That's going to leave me with the 5y on the left. The positive 2x and the minus 15 come over here. And then I'm going to divide everything by 5. So 5y divided by 5 is y. 2x divided by 5 is 2/5 x. And negative 15 divided by 5 is negative 3. So the equation of the line in slope-intercept form is 2/5 x minus 3. Okay. If you were to graph that, you would put a point at negative 3. So you'd go down 1, 2, 3, put a point right here. And then to show your slope, you would go up 2 over 5, up 2 over 5, and you would draw in that line. All right, for the second one, we have 10x minus 40 equals 0. So we add 40 to both sides, divide both sides by 10, and we get x equals 4. So that's a vertical line straight up and down. It's undefined, like we talked about before, and it's a vertical line. Find the slope-intercept form of the equation and the graph of the line that passes through the given points 1, 4, and 2, 9ths. So the first thing we want to do is we want to get the slope. So we're going to do y minus y in the numerator. We're going to do x minus x in the denominator. 9 minus 4 is 5. 2 minus 1 is 1. And that simplifies to 1. So we have a slope of 5. Nice. Now we just need to find the b. So I can use either of these 2 points. Let's use the first one because it looks a little easier to work with, right? I'm going to plug 1 in for the x right here, and I'm going to plug 4 in for the y right here, and then simplify. 5 times 1 is 5. Subtract 5 from both sides, and we get b equals negative 1. So when we substitute it into the equation, we get y equals 5x minus 1. To graph this on your coordinate plane, you'd put a point at negative 1, all right on the y-axis. And then from there, you'd go up 5 over 1, up 5 over 1. That'd be a pretty steep line. Okay. Number 2, same thing. We're going to find the slope by plugging in the formula. So y minus y, so the negative 3 minus the negative 1, and the 6 minus 9 in the denominator. So we get negative 2 over negative 3, which simplifies to positive 2/3. And then we can pick either of these 2 points to plug in. I'm going to plug in the 9 for x right there. And I'm going to plug in the negative 1 for y right there. And then I can simplify a little because 3 goes into 9 3 times, right? So 2 times 3 is 6. Subtract 6 from both sides, you get negative 7. So when you plug it into slope-intercept form, you get the negative 7 here, the positive 2/3 for the slope here, and when you go to graph this, you would put a point on the y-axis at negative 7. From that point, you would go up 2 over 3.